When doing number 8 here, remember when it says, is the speed of the particle increasing or decreasing? You're looking at both acceleration and velocity. So this is the graph of velocity. So I want to know if the speed is decreasing, that means acceleration and velocity are different signs. Okay, so let's look at the graph. This is the graph of velocity. I'm just going to get rid of, don't think of this little thing here. I'm going to look at the original graph that was given to you. So here, from 0 to k, velocity is positive. From k to m, velocity is negative. Okay, so let's look at when velocity is positive. Let's see when acceleration is a different sign, meaning negative. Acceleration, which is the derivative of velocity. So I'm thinking of the slope of the tangent line. The slope of the tangent line here is positive because velocity is increasing. That means its derivative will be positive. So that's when they're the same sign. That's when it would actually be speeding up. But here, velocity is decreasing and sorry, not velocity. Yes, velocity is decreasing, therefore acceleration is negative. The slope of the tangent line, the derivative of velocity, is negative. So from j to k, velocity is positive, acceleration is negative. How do I know acceleration is negative? Because velocity is decreasing, which goes back to golden rules. Okay, so we got j to k. Now I want to find out another place where they're opposite signs, both acceleration and velocity opposite signs. So from k to m, we said velocity is negative. So where is the acceleration positive? Acceleration is going to be positive when velocity is increasing. So that's from L to M. Okay. If I move down to number 79 here, again, always pay attention. What graph are you given? You're given the graph of the velocity, the derivative. So we have the graph of the derivative. It's asking for what is happening for f. So think of it this way. When the derivative is positive, the function will be increasing. Okay, so from 0 to 2, the function has to be increasing because the derivative is above the x-axis. It's positive. So the function has to be increasing from 0 to 2. So if I look here, that is not increasing from 0 to 2. That's out. This is not increasing. It increases, then it decreases, so that's out. From 0 to 2, it's not increasing here, so that's out. From 0 to 2, increasing, so that's still in. So I'm just doing a process of elimination. So right now we still have C and D. Okay? So now I would probably continue and I would look and say, okay, it also has to be increasing. The function has to be increasing from 3 to 4. So I look here, it's increasing 3 to 4, that's still in. It's increasing 3 to 4, that's still in. I can't eliminate anything there. Then I would probably say, okay, the derivative is negative from 2 to 3. If the derivative is negative, then f is decreasing. Okay, so let's look at it from 2 to 3. 2 to 3, it's decreasing. 2 to 3, decreasing. So again, we weren't able to eliminate anything. So now we have to look, we have to go a little bit further and we have to look at the second derivative, concavity. So when the derivative is increasing, think about what's happening using our golden rules. If the derivative is increasing, that means the second derivative is positive, which means f is concave up. So where is the derivative increasing? From 0 to 1, it's increasing, which means it has to be concave up. So that's what these little markers are saying here. This is increasing, then it's decreasing, so the function has to be concave down. Then it's increasing, so it has to be concave up. So when I look from 0 to 1, derivative is increasing. From 0 to 1, that's concave up. From 0 to 1, this is concave down. Right there, I can say I'm done. I know that the answer has to be C. But let's keep going and let's check. From 1 to 2, this is the derivative is decreasing, therefore it should be concave down. Yes, that changes to concave down. And I'm going to exaggerate it a little bit here. I mean concave up, concave down, then it goes back to concave up, concave down. So that follows that up there. Okay, hopefully that helps.